Okay, let's solve another problem. We have here an aquifer of 20 meters average thickness is overlain by an impermeable layer of 30 meters in thickness. A test well 0.5 meters in diameter and two observation wells at a distance of 10 meters and 60 meters from the test well are drilled through the aquifer. After pumping 0.10 cubic meters per second for a long time, the following drawdowns are stabilized in this well. So for the first observation well, the drawdown will be 4 meters and 3 meters for the second observation well. And we are required to determine the hydraulic conductivity of the soil layers and then determine also the drawdown in the test well. So for this problem, this is under field test in determining the permeability of a given layer of soil. So sa topic na yun, nahati yun sa dalawang category. It's either or depende lang kung nasaan mismo nakalagay yung ating test well, kung nakalagay ba yun sa ating confined aquifer or unconfined aquifer. So for us to do that, let's draw first the setup of our given problem. So we have an aquifer 20 meters thickness. So let's say this is our aquifer, 20 meters in thickness. And this aquifer is overlain by an impermeable layer of 30 meters. So ibig sabihin, nasa itaas mismo yung impermeable layer, which is 30 meters. Po pwede rin sabihin sa problem is overlain to. So nasa itaas mismo yung aquifer. So this is our aquifer, this is our impermeable layer. Po pwede rin sabihin na underlain by and then underlain to. So kailangan yung ma-analyze yung problem mismo para ma-drawing natin maayos kung ano yung setup ng ating layered soil. Dahil kapag nagkabaliktad mismo yung aquifer at saka yung permeable layer, mag-iiba yung formula na magagamit natin. So maiba yung makukuha nating sagot. So we also have a test well that is 0.5 meters in diameter and two observation wells which is 10 meters and 60 meters ang distance sa ating test well. Since yung distance, walang sinabi ko ano yung distance na yun, make our distance always a center to center distance. So ating 10 meters mas malapit, then yung mas malayong observation well is 60 meters in distance. And then we also have here a given value for the flow rate. And the flow rate is 0.10 cubic meters per seconds. So, kailan natin yung ating hydraulic conductivity. That is unknown. So, dalawa yung ating category dito. Since nandito yung ating aquifer, nasa ilalim mismo ng ating impermeable layer, that is under confined aquifer. So, yun yung formula gagamitin nyo ng K. Pero kapag yung aquifer layer natin ay nasa pinakataas na layer, that is under unconfined aquifers. Ibang formula naman for hydraulic conductivity. So, for confined aquifer, under field test of permeability, K will be equivalent to Q ln of R1 over R2 over 2 pi T multiplied by H1 minus H2. So let's define the parameters for this given equation or for this equation. K will be the hydraulic conductivity, that is our unknown. Q will be the flow rate. And then R1 will be the distance of the farther test well or the distance of the farther observation well from the test well. And then yung R2, yun yung distance ng mas malapit na observation well from the test well. And then T here is the thickness of the aquifer. So that is given the problem. H1 and H2 will be the height of water level in the observation wells. So dito, wala pa tayong height. Dahil wala pa tayong binigay sa problem kung nasaan mismo yung ating groundwater table. So let's assume nandito yung ating groundwater table. And then magkakaroon daw tayo ng drawdowns. So hindi natin alam kung nasaan mismo yung depth ng ating water table. So let's say this is a height of h, yung height mismo ng ating water table from this datum line. And then, sabi sa problem, magkakaroon daw tayo ng drawdown sa ating dalawang observation well. 4 meters and then 3 meters. Papunta doon. So, ibig sabihin, itong drawdown na to, habang pinapump yung well natin, yung depth ng tubig ay nababawasan sa ating mga wells. Since dito mapapansin naman natin sa drawing natin, mas maliit yung ating drawdown, so that will be 3 meters in drawdowns. Then mas malaking value na drawdown, that is 4 meters. So yung H1 and H2, yun yung height ng tubig, yung level daw, which is unknown. H1 will be the height of water level in the farther observation well. This is H1 and this is H2, yung mas malapit na observation well sa test well. And we can see that in our drawing that H1 is equivalent to H minus 3 and then H2 is H minus 4. So we can say that H1 minus H2 is equivalent to H minus 3 minus quantity H minus 4, and that will be equivalent to 1 meter. So meron tayong value ng H1 minus H2. So substitute natin lahat ng given parameters. Q will be the flow rate in our layered soil, 0.10 cubic meter per seconds. Loan of R1, yung distance ng mas malayong observation well sa ating test well, that is 60 meters. Over R2, yung distance ng mas malapit na observation well from our test well, so that is 10 meters. Center to center, so that is over 2 pi. T will be the thickness of our aquifer. The thickness is 20 meters. And then H1 minus H2, we already have the value 1 meter. So cubic meter yon, square meters to, kakancel, the unit will be, kakancel din yon, the unit will become meter per seconds. So computing the value of K, we will get a value of 0.0014258 meter per seconds. And that will be the requirement for our first unknown. Yung second unknown, determine the drawdown in the test well. Ano naman daw yung drawdown sa test well? Yung pagbaba ng level ng tubig. So that is S. Hindi natin alam. So para makuha natin yon, we will use our computed hydraulic conductivity here. Again, that is under confined aquifer pa din. Gagamitin lang natin, so para makakuha natin to, i-relate lang natin yung drawdown nito sa drawdown dito sa mas malayong test well. I-relate natin ito sa mas malayo para mas critical yung ating drawdown na mas makukuha. Kapag dito, hindi masyadong critical yung value na ating makukuha. So, palagi i-relate mismo yung drawdown ng ating test well sa pinakamalayong observation well. Okay, so for us to do that, again, formula for hydraulic conductivity for confined aquifer is K equivalent to Q loan R1 over R2 over 2 pi T H1 minus H2. So, i-consider natin ngayon is yung ating test well at saka yung mas malayong observation well. So, H1 palagi yung height ng tubig na nasa mas malayong well, and that will be still H minus 3. Then H2, yun yung height ng tubig na ina-analyze sa mas malapit. Since mas malapit, ito na mismo sa ating, na mas malapit sa ating test well. Since yung test well na mismo ina-analyze natin, we can say that H2, nandito yun, is H minus S. Ito yung magiging bagong value ng H2 natin. Since ito na yung pangalawang well na ating ina-analyze. So, we can say that H1 minus H2 will be H minus 3 minus H minus S. So we can say that H1 minus H2 is S minus 3. So substituting the given values, K will be, nakuha na, 0.0014258 meter per seconds, equivalent to Q, the flow rate, 0.10 cubic meter per seconds, load of R1, yung distance ng mas malayong observation well, that is 60 meters, over R2, yung mas malapit. Since center to center tayo, nandito mismo yun, yung distance na yun, yung R2 natin will be half of the diameter of our test well, so that is 0.25 meters over 2 pi multiplied by the thickness of aquifer, 20 meters, multiplied by H1 minus H2, which is S minus 3. So by cross multiplication, isa lang unknown dito sa ating equation na to, we can get for the value of the drawdown in our test well. And we can get S equals or equivalent to 6.06 meters. And those are the requirements for this given problem.